I we're going to continue with section 2.2 and look at a couple of specific functions. First of all, I do want to kind of remind us what functions are. Functions or graphs of functions, first of all, must pass that vertical line test. So I have drawn a couple of really weird looking functions. This one, if you pass it through, it does pass that vertical line test. One place that's a little bit questionable is right here, but notice we have a solid dot and an open dot. Since we don't have two solid dots, this is considered a function. I have another one drawn here. Again, here we have an open dot, closed dot, so that does pass that vertical line test. They stop and start again. And then I do have this guy, which we'll talk a little bit about as well. But again, it does have little pieces to it, so we'll talk about those. First thing I want to talk about is by looking at a graph, how can we find what our domain is and what our range is? And we can do this using a graph a little bit easier as far as range goes. By looking at a graph. A lot of times finding the range looking at formulas like we saw in 2.1 is very difficult to do. But if we have the graph, we can see it a little bit more clearly. I want to remind us again that domain is the inputs, range is those outputs. I like to think of the domain also as the x's, what we're putting into the functions. The outputs are our f of x's, which when we're talking about a graph are the y's, what's coming out. So when I'm looking for domain, I'm thinking xy's, so looking at that x-axis. So as I look at this x-axis, what has values? So where do I see the graph? If I'm looking at a certain x value, looking up and down, is there something coming out? So the smallest x that I see something coming out is this guy right here, which happens to be -4. And I'm going to put my answer in interval notation. I do have a value coming out at -4, so I'm going to include him. And as I move along the x-axis, I see that all of my values have something coming out. Here I have this solid dot, and as soon as I pass it, I'm on this line. So I'm continuing to see stuff until I get to this value right here, which is 1, 2, 3, 4, 5, 6. But I have an open dot. So my domain is everything from -4 up until 6. But since I don't have a value at 6, we'll use a round bracket for that point. So there's my domain, the values that went into this piece to get something out. Now the range is what did we get out. So now I'm going to look along that y-axis. So looking, starting at the bottom, because that's the negatives. When we read the x's, we go left to right. When we read the y's, we'll start at the bottom and go to the top. And I'm going to be looking to the left and right to see if I have values coming out. The smallest y value I have is right here, and that's at -3. I do get that value, so I will include it. Now notice I have values all along the lines, don't have any gaps until I get up to this value. So no gaps until I hit and I get something out up until here, 1, 2, 3, 4, 5. But I did not get 5 to come out, so we will see that round bracket. It is possible to have jumps and gaps, but we will write it that way. So notice, even though we had a jump in the curve, I was still getting values out from 4 until 5. Okay, here's another one. And in this one, we're going to go a little bit further because this is made up of pieces that we're familiar with, basically just straight lines. So I'm actually going to come up with the equation for this graph. And we'll notice that this has pieces. So this is, to get that equation, it's going to be a piecewise function. This would also be a piecewise function because it's got pieces. However, we haven't figured out how to get the equations for those pieces, except for possibly this one. I don't know the equation for this curve here. But since I have straight lines, I can actually come up with the pieces. But let's again go through domain and range, just as practice. Okay, domain, notice we have an arrow, which indicates that this continues on down the line and never stops. So that means all of my x's have something. Here I do have a value. Here I do have a value, and this continues on up. So my domain is all real numbers, or the entire real line. My range, again, now looking wise, the smallest value I have is 0, but I don't actually get that value, and I continue getting values coming out, looking left and right, all the way up, so 0 to infinity. And now we're actually going to come up with an equation for this one. So we're going to find the formula, or find the piecewise function. This function. And I don't care what we call it, so let's just call it f, because that is the most common. And we have 3 pieces of our function. Okay, so I'm going to kind of have 3 different pieces. I'm going to have this one. So I'm going to put in my qualifiers first, because my qualifier for this piece here is going to be for x's less than -1. Okay, if I'm equal to -1, I'm up on this line. So I'm going to be from -1 to here, so -1 including the -1 up until 2, but I'm not going to include the 2 because I have an open dot. When I'm at 2, I jump up to this curve. So for x's greater than or equal to 2, we're going to be on that piece of the line. And now what we need is equations for all of those pieces. And these are straight lines. So this is the equation of a straight line. Notice it is horizontal. So those look like y equals a value, and it's going to be y equals 1. But instead of y, we have f of x. So this piece is just f of x equal to 1. So no matter where we are down here, we're going to take on the value 1. This is a straight line. Y-intercept at 2. Slope is going down, down 1 over 1. So -1 x plus 2. Or just -x plus 2. Probably should write that as -x plus 2. Instead of the -1x plus 2. Slope, intercept. Here we also have a straight line. Slope on this one is up 1, 2, and over 1. So I've got a slope of 2. And I'm going to use my point slope form. So here is the point 2, 2. So 0.22, so y minus 2 equals 2 times x minus 2. And now I'm going to solve this for y. Y minus 2 equals 2x minus 4. Add 2 to both sides. 2x minus 2. So that's what's going to go into this last piece. So here's a piecewise function that represents this graph. So we could go both directions. The last thing in this section that I want to talk a little bit about is this greatest integer function. The greatest integer function, first of all, is defined with this funny symbol. We've got these double barred x's. Kind of looks like absolute value, but it's not. And this sometimes is also referred to as a step function, because it does look like we're going up little steps. The thing to kind of look at is if you look at these values, and I want you to kind of think of them in their decimal forms. So if I had f of 1.5, okay, 1.5 is here, we would have a value of 1. What it does is it takes this and says, what is the largest integer So integer values 1, 2, negative 1, 0. That is smaller than me. The biggest integer, but yet smaller than me. So the biggest integer that's smaller than 1.5 is the number 1. If I'm looking at 3.7, it would be 3. It's kind of like just truncating the decimal off. When we have negatives, we actually have to go down. So the negatives are going to go down to that negative 2. So the largest integer that's smaller than me. And when we get to the actual integer, the largest integer that's greater than or equal to me, or smaller than or equal to me for 1 is 1. There are multiple integer functions out there. Some of them will have the open dot here and a closed dot here, and they have a slightly different symbol. So I just kind of wanted to make you aware of these functions. They are out there. They are used a lot of times in pricing. So think of your cell phones in the old days when we got price per minutes. So for 1 minute to 2 minutes, we got a certain rate. For 2 minutes to 3 minutes, we bumped up to a new one, and so forth. So that's where these step functions show up, is in those kind of chargings by like hours. So for the first couple hours, we're at this rate. Once we get to 5 hours, we're at this rate. If we go to 7 hours, we're at this rate. So these are where those step functions come into play. We will be continuing looking at graphs of functions, domains, and ranges as we progress through Chapter 2. So take your time, make sure you read the chapters, make sure you look at the videos that are found in WebAssign, make sure you read the textbook, make sure you also ask questions. So if you are struggling on something, please send me an email, let me know where you're struggling, and we can talk.